Hi, and thanks for watching this video about my Homebrew computer. Today I wanted to demonstrate the serial port. Previously I had serial, but also with a real-time clock, two different chips. I'm using the 6551 ACIA serial chip. I was having a bit of noise and interference and instability, so I removed the real-time clock and I've rejigged things. So here you can see where I've now put the serial chip on a mini breadboard, acting like a kind of daughter board. Although it doesn't look it, this is a slightly cleaner and simpler setup than I had when previously a large daughter board with the real-time clock. So this serial chip is connected to the transmit and receive lines of a serial cable, which is going into from the back of the Homebrew here, and then it's just a standard serial TXRX with ground going to a serial to USB converter, a small USB dongle, which then allows the PC to see a COM3 port essentially as a serial port. And I can communicate over using a terminal program like TerraTerm to if I don't want to use the Homebrew computer's keyboard, I can do whatever I want through terminal access. But what I really wanted to do serial for ultimately was to be able to transfer files from the PC to the Homebrew, because I would often be creating files on the PC, and the only way to then transfer them to the Homebrew was to, over here where I've got, you can see my pen, the SD card, was to pop the SD card out of the Homebrew and then put it into the PC, transfer the file and back again. No big shakes, but I still wanted to be able to do it while the Homebrew was actually running. So that's what I want to show. I did look at standard protocols like X and Y and Z modem. I don't know, for whatever reason, I actually found those quite difficult to implement, and the ones that I did implement, but when I did implement, I found it not the best speed, and standard terminal software seemed to not all work the same way, so I couldn't rely on my terminal software sending the information the same regardless of which application it was. So long to story short, as it's a Homebrew computer project, I decided to create a Homebrew protocol. So what you can see on the screen here is a little overview of that protocol. So I created a serial protocol which is block orientated. Each block is 253 bytes long, which is consists of a block number followed by how much of that block is the payload, up to 250 bytes, then the payload itself, and then any remaining up to 250 of padding and a checksum. So each block, that means, is always 253 bytes long. The block number is important because block 0 indicates it's a metadata block and doesn't actually have a real payload, because the metadata I want to send to the Homebrew is what's the name of the file that it needs to create on its SD card, and which folder does that file need to be created in. So other blocks, which are non-zero block numbers, are standard payload blocks. And the protocol is here. It's a fairly simple protocol, not that dissimilar to something like XMODEM, I guess. Start of header is starts the overall transmission. It's an ACK based. Each block has to be ACKed by the Homebrew, and after the final block, I send an ETB, which also has to be ACKed. And at that point, there, the Homebrew knows to close the file handle on its side, so the SD card can have the file finalized on its file system. So that's what it is. I found that this protocol seems to run faster than when I was trying it out with XMODEM protocol. So let's show that. So firstly, this protocol definition here is part of my PowerShell script, which essentially implements this protocol. So I'm not going to go into the PowerShell script. The point is that's what it is. And on here, I have a PowerShell window, so I can try to execute this send protocol. So what I'm doing here is sending to the Homebrew over COM port 3 a file on the PC, which is in that folder. It's called tetris3.prg, and I want to put it on the Homebrew computers folder of /test/data. So let me just show you that. So in my Homebrew computer, I have a test folder called test, and in there I've got a folder called data, and that's where I want the file to appear when I send it. Now, how does the Homebrew exchange or know that the protocol is running? I have a monitor, my monitor, which is normally my debug program for helping me to look at memory, etc. I've implemented the protocol on the Homebrew side with this command called receive, recv. So I had to start the protocol on the Homebrew computer. So let's start it. And then it's now waiting for the SOH from the PC. And when I press enter, that's what will happen. I thought what we'll do is time this and see what the performance looks like. So I've got my stopwatch here. So as you can see, there's a question mark, which is the Homebrew is waiting. So I'm going to press enter. And as soon as I press enter, I will also press start, stopwatch. Then I'm going to watch this until I see that the PowerShell script is finished. So I don't know, maybe I was a little bit slow on stopping that, but that will do. 11.8 seconds, and you can see on the monitor that there were 15,851 bytes that were transferred. So let's work that out in terms of my calculator. So I'll just put my calculator up on here. Should have got my calculator from the beginning, shouldn't I? So I've got 15,851 divided by 11.8. So that is just over 1,300 bytes, 1,343 bytes per second. Now each byte is 8 bits of data plus a stop bit, so let's multiply that by 9. So I'm getting essentially 12,000 bits per second, but the transfer is at 19,200 BPS. So the reason why it's not 19,200 is because obviously the serial data transmits at 19,200 from the PC. Then the Homebrew has to take that data, write it to disk, and then write the acknowledgement for the next block. So naturally, whilst we're waiting for the Homebrew to do its thing, can't be transmitting another block. So that's the reason why it would obviously be lower. But I'm quite pleased with this because being able to transmit, in the region of 1340 odd bytes per second means that even this program, this Tetris program, which is one of the longer programs I've written on my Homebrew, only takes like 10-11 seconds to transmit. So that's my Homebrew computer doing file transfer. Thank you for watching.